In this last section in Chapter 13, we're going to take a look at some applications of right triangles. And what we're asked to do in problem number 1 is to solve the triangle. Now what that means is when you're asked to solve a triangle, it means that you want to find the unknown parts. So what we have here is that we have this angle, we need to find this angle. We have this side, and we need to find these other two sides. Then everything will be known in this triangle, all the angles, all the sides. Well, first of all, we know this, that if we add up these angles, this plus angle B, we should get 180 degrees. That is, if we take 15.4 degrees, add to that the measure of angle B, plus this 90-degree angle, right, this one right here, that right angle, we should get 180 degrees. Now, adding these two together, we get 105.4 plus angle B, that's 180 degrees. And then, if we subtract 105.4 from each side, we're going to have this. We're going to have the angle B is equal to 74.6 degrees. So now we've got all three angles. We just need to get these other two sides. Now, let's see if we can get this side, the length of this hypotenuse here. Now, normally what we try to do is use the Pythagorean theorem, right? A squared plus B squared is C squared. But we don't have both of those numbers. If we had B, we could do it. But we have only one, so we're not going to be able to use the Pythagorean theorem. We have to come up with something else. Now, we're going to use some trigonometry here, and here's what we know with our trig functions. We have this angle here, and we have the side opposite that angle. Now, look at these trig functions here. What we're trying to get is the hypotenuse. We have an angle and the side opposite that angle. So look right up here at the sine. We have the sine of an angle. Now we have an angle. And then the sine is the side opposite. We have the side opposite over the hypotenuse. That's what we're looking for. So why don't we use this right here? So we know that the sine of this angle is the side opposite the angle over the hypotenuse. So let's put our numbers in here. So we have the sine of 15.4, which we'll get on our calculator. This is equal to the side opposite, which is 6.4 over the hypotenuse, which is C. Now, we have an equation here that involves a fraction. We always deal with these the same way, right? We get the LCD, which is C, and we multiply by the LCD. So what I'm going to do here is I'm going to multiply by C. And doing so will give us C times the sine of 15.4 degrees. That's equal to 6.4. And now to get C, let's just divide by the sine. So we're going to now divide by this sine. So we will get C is equal to 6.4 divided by the sine of 15.4 degrees. And let's do that up here. So I'm going to type in on my calculator, I'm going to type in 6.4, divide, press the sine key, type in 15.4, close the parentheses. Now when I did that and pressed enter, I got 24.100 ... So why don't we just round to one decimal place and we'll get C is equal to 24.1. So we're doing pretty well. We're given that angle. We got that angle. We know that angle. We have that side. We just got that side. We just need one more to solve the triangle. We need B. Now we have this side and this side. We could use the Pythagorean theorem and get this side. But why don't we use some trigonometry, just like we did to get this side in order to get B. So to get B, here's what we have. We have this angle, and we now have the hypotenuse, but I want this side adjacent. So here's what I could do. To get B, we have our choice here. Here's what we can do. We have an adjacent side, right? Given this angle, we have a side adjacent and the hypotenuse. Now that turns out to be the cosine, right? The cosine is the side adjacent over the hypotenuse. Now using this, we're going to get the cosine of A, which is that 15.4. That's equal to B, which is what we're looking for, over the hypotenuse, and we just decided that was 24.1. So if we multiply by 24.1, we'll get 24.1 times the cosine of 15.4. And when I got that, I got 23.23 dot, dot, dot. So why don't we claim now that B is equal to, let's say, 23.2. Let's get this angle. We want to solve this triangle. We can get this angle here because we know that 30 degrees plus 90 degrees is 120 degrees, and these three have to add up to 180. So this is going to have to be 60. So we know that angle B is 60 degrees. Now what we can do now is, why don't we use this 30 degrees, and I have a side opposite and the hypotenuse. So what I'm looking at is a side opposite and a hypotenuse and an angle. So I've got the angle, I'm looking for the side opposite, and I have the hypotenuse. So there's three things. There's the angle, the side, and the hypotenuse. We have an angle, hypotenuse, we can get the side. I've got 2 out of the 3. Why don't we use the sine of A, this angle here, to get this length right here? So we're going to get that the sine of 30 degrees is equal to, right, the side opposite, which is A, right, the side opposite that angle is A, divided by the hypotenuse, and the hypotenuse here is 18. All right, so let's multiply by 18. So we'll get 18 times the sine of 30 degrees is A. So I'm going to type in an 18 on my calculator. I'll press the sine key, type in 30, and close the parentheses. And that's A. I got A to be 9. Now, what we want to do is we want to get B. So let's do something different than we did in the last problem. To get B, well, here's what we could do. We could use, look what we have here. We have this angle. We're looking for this B here. That's the side adjacent to that angle over the hypotenuse. Now, the side adjacent over the hypotenuse, that's the cosine. So we could use the cosine of 30 degrees is equal to B over the hypotenuse. We've got it here. Let's just go ahead and finish. So we're going to multiply by 18. That'll give us 18 times the cosine of 30 degrees. That's equal to B. And 18 times, now the cosine of 30 degrees, if I make that multiplication, I'm coming out with 15.58, something like that. So I'm going to get B equals, I'm going to round this to 1 decimal place. How about 15.6? I got 15.58845 and so on. But I'm going to round to 1 decimal place. So I've got B. But let's try something else here too. You know, we have this angle up here, right? I'm going to draw that over here. Here's where we're at. This is 30 degrees. That's our right angle. This is 60 degrees, and that's angle B. We said that this is 18, and this one we found to be 9. And we're trying to get B. Now, what we have is this. If we use angle B instead of angle A, now we used angle A over here, but let's use this one, see what happens. Look what we have. We have an angle, we have the side opposite the angle, and we have the hypotenuse. So I've got the angle, the side opposite, and the hypotenuse. Now that's the sine, but of angle B. So we could try here. Let's see what happens. This is the sine of B, which is 60 degrees, and that's equal to, all right, the sine is the side opposite, and the side opposite, our angle, is B. That's what we're looking for, over the hypotenuse, which is 18. So now if we multiply by 18, we'll get 18 times the sine of 60 degrees. That's equal to B. And sure enough, when you make that multiplication, you get that 15.588 ... So we're going to round off to B equals 15.6. So we've got two ways to get B. We want to solve this triangle. Now we're given two of the three sides and one of the two angles. Now we could get this side here using the Pythagorean theorem. In fact, why don't we just do that? So doing so will give us a squared plus b squared equals c squared. A squared we don't know, but b is at 1.82 squared equals c squared, 4.72 squared. Now let's subtract this number here. So we'll get a squared equals 4.72 squared minus 1.82 squared. On my calculator, I'm going to type it in like this. 4.72 caret 2 minus 1.82 caret 2. Okay, so that gives me that a squared is equal to 18.966. And then when I take square roots, I get the square root of a squared is the square root of 18.966. Now, because a is positive, the square root of a squared is a. And when I take that square root, I'm going to get 4.3549 ... The problem says to round to the nearest hundredth. So let's go to two decimal places. So I'm going to write this as 4.35. So we've got a. Now, why don't we get this angle A here? So here's what we know. What do we have here? Well, we have, I want that angle, so I've got an adjacent side and a hypotenuse, but I also have the opposite side and the hypotenuse. So the opposite side and the hypotenuse, that's the sine, but the side adjacent and the hypotenuse, that's the cosine. You know, I think what I'm going to do here is I'm going to use the cosine because maybe when I did this, I made a mistake and I got the wrong number here. So I would not want to use an incorrect number here. This one we're given, so let's use the given. So we're going to have then that the cosine of A is equal to, now this is a cosine, here it is, it's the side adjacent, and the side adjacent, that's the 1.82 divided by the hypotenuse, which is 4.72. Now we actually want A, so A is going to be the angle whose cosine, right, the inverse cosine of 1.82 divided by 4.72. So this is the stuff we did in the last section. So here's what we're going to type in the calculator. We're going to press second. So press the second key. Then you're going to press the cosine key. And right above it, you know, is the inverse cosine. So that'll give you that will give you this. That will give you inverse cosine and a parentheses. So type in the 1.82 divided by 4.72, and doing so gave me 67.319 ... So how about if we round off to one decimal place? So I'm going to get this. I'm going to get that angle A is 67.3 degrees. Now I want to get this angle B here. I want to get angle B. Now, we just found angle A. Right down here, we found angle B to this number, this number here. So that would give me 67.3 plus 90. Subtract that from 180, I could get this. But what if I made a mistake in these computations and I get the wrong number here? Then I would get the wrong number for B. So why don't we use what's given already and use that to get angle B? So looking at B, I'm given the side opposite of B and the hypotenuse. Now the side opposite and the hypotenuse, that's going to be the sine, not of A, but of B. So we can write the sine of B is equal to the side opposite, 1.82, over the hypotenuse, 4.72. And then B is going to be, right, this is going to be the inverse sine of 1.82 over 4.72. Now, careful, it looks similar to this one, right? But this is the inverse cosine. We have the inverse sine, even though we have the same numbers here. And when I press, okay, here's what I'm doing, right? We're going to go with second. So you press the second key. Then you press the sine key, because right above sine is inverse sine. So that gives you this on your calculator. Inverse sine parentheses, put in the 1.82, divide by 4.72, and when I did that and pressed enter, I got 22.68 dot dot dot. So how about if we just say now that B is equal to 22.7 degrees. So now we've got everything that we're looking for. We've got our angle A right here. We've got our angle B right here. We got our side A, that's what we got first, right here. So we have all three sides and all three angles. This triangle is solved. To solve this triangle, how about first up, we notice we've got a 90-degree angle, a 31-degree angle, and we need to get that angle here. So we know that 90 plus 31 plus that angle is equal to 180. So we know that 31 degrees plus 90 degrees plus angle B is 180. That's 121 plus angle B is 180 degrees. So if we subtract that 121 from both sides, we're going to get angle B being 59 degrees, all right? So let's say B is 59 degrees. So we've got all three angles now. We need to get two of the sides, right? A and B, or A and C. We already have this side. Let's get one of them here. We know that we have this, all right, according to this angle here, we have the side adjacent and the hypotenuse. So we could use the side adjacent and the hypotenuse. We're trying to get the hypotenuse. Well, here's the adjacent and the hypotenuse. Let's go with the cosine, right? So let's try this. Let's say that the cosine of that 31 degrees is equal to, now, the cosine is the side adjacent to the angle. Here's the angle. The side adjacent is 46. So we're going to write a 46 here over the hypotenuse, which is C. So we're going to multiply by C. So we'll get C times the cosine of 31 degrees. That's equal to 46. Then we're going to divide by the cosine of 31 degrees, and we will get C equal to 46 over cosine of 31 degrees. And I'm going to round off here. I got this. I got C being 53 point, and they're asking us to go to 2 decimal places. So how about 0.67? Now, we still need to get A here. How about if we try this one? You know what? We got this 31 degrees. That's given, so we know that number's correct. This number's correct. We're given that. I'm hesitant to use C because I had some computations. Maybe I got it wrong. I don't want to use an incorrect number. And I computed to get B. Maybe I got that one wrong. So let's use what's given if we can. So here's what we're given. We know this angle. This is the side opposite. That's what we're looking for. This is the side adjacent. So what do you have? You have an angle, the opposite, and the adjacent. So follow it over here. Here it is. You have the tangent of that angle is the opposite over the adjacent. So let's try the tangent. So we can write now that the tangent of 31 degrees is the opposite, which is A, what we're looking for, over B, which is the adjacent, 46. Let's multiply by that 46. We'll get 46 times the tangent of 31 degrees, that's A, what we're looking for. And when I make that multiplication, I got A being 27.6395, so on and so on. I'm going to round to 2 decimal places. I'm getting 27.64 to 2 decimal places. So now we have all 3 angles, right? We have the 31, the 90, and the 59. We've got all 3 sides. That one was given at 46. We found C down here to be 53.67. And then we found A using the tangent to be that 27.64. So we've got this triangle solved. We want to solve this triangle here. Now we're given 2 sides, 6 and 3, and we don't know this. This is a C. Let me write that a little bit clearer. This is actually a 6, and this here is a C. So we have 2 of the sides. We can get the hypotenuse. Now, these angles here's what these things are. This letter here, that's the Greek letter alpha. And this letter here, that's the Greek letter beta. So instead of calling these angles A and B, we're just going to call them alpha and beta. Now, do you believe that we could use Pythagorean theorem to get C? We can. I'm not really going to do this. It's going to be this. It's A squared plus B squared is C squared. We'll get 6 squared plus 3 squared equals C squared. Well, I said I wasn't going to do it. Now I'm doing it. 36 plus 9 is equal to C squared. 45 equals C squared. And if you take the square root of 45 to get C, I'm getting about this. If I round it off, I'm getting 6.7. Now, let's see if we can get angle alpha. So what I'm going to try to do here is I'm going to get alpha. And what I know is I have an angle, and I have the side opposite and the side adjacent. Well, that's a tangent. Opposite over adjacent, that's a tangent. Now, look, I've got this number here, but remember, I got that by computing. Maybe I made a mistake, so I'd prefer not to use that. I will if I have to, but I don't think we need to in this case. I've got an angle, opposite, adjacent. That's going to be the tangent. So let's write that the tangent of alpha is 3 over 6. And then using our inverse functions, we'll have that alpha is equal to the inverse tangent, the angle whose tangent is 3 over 6. So on your calculator, you're going to press the second key, then you're going to press the tangent key, right? Because right above it is that inverse tangent. And that'll give you this. That'll give you inverse tangent parentheses, 3 divided 6. And when I did that, I got 26.565, round off to 1 decimal place according to the problem. So I'm going to have this. I'm going to have that alpha is equal to 26.565. I'll round it up to 26.6 degrees. Now I'm going to use the same idea here to get beta. Look at beta. You've got an opposite over adjacent. All right, so opposite over adjacent, that's a tangent again. So why don't we try this? Let's go with the tangent of beta is the opposite, which is 6 over 3. Let's just be sure we got it. The tangent of our angle is the opposite, 6, over the adjacent, which is 3. So beta, that angle is going to be the angle whose tangent, the inverse tangent, of 6 over 3. So again, we're going to press the second key, then the tangent key, because right above it, that's our inverse tangent. And that is going to give us the inverse tangent parentheses, 6 over 3, or just type in the 2. In doing so, I'm getting this. I'm getting that beta is 63.4349 and so on, but we want to round just to 1 decimal place. So how about this? 63.4 degrees. So I think we have this solved, right? We have all 3 sides. I got the 3 and the 6 that was given, but we have the C. Pythagorean theorem gave us that. And we have the alpha that was here. We used the tangent, inverse tangent, and then we used, for beta, we used the tangent and the inverse tangent. We've got them all. Let's try to find the height of this building here you know what, let's call the height of this building, since we don't know what it is, let's call it, say, h for height. And now what we're trying to do is find h, given we know the angle and we know the side adjacent to the angle. So here's what we know. Look what we've got. We've got an angle, the side adjacent, and an opposite. We've got an opposite, adjacent, and an angle. So where are we here? We have an opposite and an adjacent and an angle. So how about this one here? The angle, the opposite, and the adjacent. So let's go with the tangent. So we're going to write the tangent of 29 degrees is equal to the opposite, which is h, what we're looking for, over the adjacent, which is 78. We'll multiply by 78, and we'll get 78 times the tangent of 29 degrees, that's h. So we're going to type in 75 times, we're going to press that tangent key, and that'll give us the tangent with the parentheses. We'll type in 29, and then we'll press enter. And when I did that, I'm getting that h is equal to, I got 4, 3, 2, 3, 6, and so on, and the book is asking us to round to 2 decimal places. So how about 43.24? So we're going to say the height of the building, 43.24 feet. Number 7, they're telling us that we've got a ramp. So here's this ramp, and the ramp is 89 feet long from the base of the ramp to the top of the ramp. And from the base of the ramp over to here is 60 feet. And what we want to do is get this angle. Now, I think we've seen this one before. This is the Greek letter theta. Oh, come on now. Let me try that again. The theta. Well, look at what we have. We're trying to get this angle, and we've got an adjacent side and a hypotenuse. Now, adjacent and hypotenuse, maybe we're getting used to these now. Here it is. Adjacent and hypotenuse with our angle. That's a cosine. So why don't we use this? Let's use cosine of theta. So what we're going to get is the cosine of theta is the adjacent, right? It's the adjacent, and adjacent to this angle is 60. So we're going to get 60 over the hypotenuse, which is 89. But we want theta itself, so theta is the angle whose cosine, or the inverse cosine, of 60 over 89. So press the second key. Press the cosine key, because right above the cosine key is the inverse cosine. And that'll give us the inverse cosine parentheses, put in a 60, divided by 89. And I'm getting theta to be, now to 1 decimal place, I'm getting 47.6 degrees. So in this last problem that we're going to do, we've got a plane here, and it's at an altitude of 15,200 feet, and here's our eyeball right here, so maybe, we're looking at it right here. That's us looking at this. And the distance from the perpendicular from the plane to us is 16,600 feet. And what we want to do is we want to find this angle. If you're looking at this plane and you look up, what angle would that be? Maybe we're getting the idea here. We've got an angle, and look at these sides. What do we have? We have an opposite and an adjacent. Angle, opposite, and adjacent. I think that's a tangent. All right, let's take a look here. Here's our angle, opposite, and adjacent. Angle, opposite, adjacent, and over here, the angle, the opposite, and the adjacent. So let's use the tangent. And we can write that the tangent of the angle that we're looking for is the opposite, which is 15,200, over the adjacent, 16,600. So that theta, that's the angle whose tangent is 15,200 over 16,600. So you're going to press the second key. You're going to press the tangent key, because right above it is inverse tangent. And that'll give you the inverse tangent with a parentheses. And then you write 15,200 divided by 16,600. And when I did that one, I got theta to be, I got 42.47917 and so on. So I'm going to round to just one decimal place. So how about 42.5 degrees?